Hello, this is Anthony with Copley Controls. I have an Omron controller here commanding a TE2. I'm updating the network. The PDO update cycle is 1 millisecond, so 1,000 microseconds, 1 millisecond. And I have a program in here that is a ladder logic program inside of the controller, and I'm just going to make some dual axis moves here. So I'll just go into this rung to enable the axes for motion, and then I'll go in here and actually make the moves. So both moves start and stop at the same time. At the same time, I'm connected over serial to CME software, and I made a scope trace. So I can zoom in here, and we can see the position. The blue, the blue is commanded position, and then we can see the right below it is this orange is the actual. So there's a slight delay here, you can see that, but it pretty much matches commanded versus actual, and you can see here in the measurement tab it matches our PDO update rate, 1 millisecond. So every millisecond we get a new commanded position from the Omron controller and we go there. That's how CSP mode works. Now watch what happens when I take this same move, the same mode, and I turn on interpolation in the drive. Okay, so with interpolation turned on, we can see that the actual position now looks more like a straight line instead of the staircase profile. So now we are interpolating because we know that the update rate coming in over the network is 1 millisecond, so we're able to kind of thread the needle here and make more of a straight line profile. And so we're getting much smoother motion because we interpolate between the positions using the drive's update rate. So inside the servo drive, the control loop, it closes the position loop every 250 microseconds. So that's how we're able to take advantage of the drive's servo loop. So every 250 microseconds, we're able to create a new commanded position that gets us eventually where we want to go with to the master's position. So it's connecting the dots. Instead of these big jumps in position, now we're getting a much smoother profile, more straight lines instead of staircases. So the Omron PLC, it updated the drives, it set the drive's interpolation time period by sending SDOs to these objects. So our interpolation time was 1 millisecond. So every millisecond, the PDOs were transmitted from the controller down to the drive. So that's what we have to set in here is 1 millisecond. So we set this to 1, this first subindex. 60C2 subindex 1, we set that to a value of 1. And then 60C2 subindex 2, we set that to a value of -3. So it's basically 1 times 10 to the -3. 1 times 10 to the -3 is 1 millisecond. So that's how you set the interpolation time period in the drive.